Problem number 45. We want to evaluate the line integral of f is 2xy plus 1 comma x squared over the curve that's line segments from 0, -1 to 0 to 1, 0 to 0, 1. Let's just draw that really quick. 0 minus 1 is going to be right there. To 1, 0 is there. To 0, 1. Okay, so this is the curve that we want to integrate over. We're asked to use Green's theorem to do this. Green's theorem only works if we're integrating it around a closed loop. We don't currently have a closed loop, and so that means that we have to close up our loop. And so how are we going to do that? Okay, let's make C1 from the point 0, 1 to 0, -1 here. And so now what we know is that the integral over C of f dot dr plus the integral over C1 of f dot dr. So this is a closed loop integral, a circulation, remember that term here. And so this is equal to the double integral over r of the partial derivative, and we call this m, and this n, partial derivative n with respect to x, minus partial derivative of m with respect to y here. Okay, so let's see. This is the thing that we want here. So it's equal to this double integral. And let's see, partial derivative n with respect to x is going to be 2x minus partial derivative m with respect to y is going to also be 2x. Minus, move this integral to the other side here, f dot dr. And so this integral here is 0. And so now we see the reasoning for using Green's theorem here is that we are evaluating two line integrals for one line integral because we already evaluated this double integral and it's 0. Okay, so next up we have to evaluate, that C sub 1 there fell off of that, my apologies. Now let's evaluate this line integral. We need to parameterize from 0, 1 to 0, -1 here. Think of parameterization that works. Well, the x-coordinate is always going to be 0. And then we can make it go from 1. Okay, we do 1 minus t. When t is 0, we are at 0, 1. When t is 2, 1 minus 2 is -1. That checks out. Here's r of t. R prime of t is 0, -1. F of r of t. We need to plug things into our vector field f here. 2 times x here. So we need to use r of t, not r prime of t. R of t is 0 times y is 1 minus t plus 1 comma x squared here is 0 squared. So that is 2 times 0 times 1 minus t is 0 plus 1, 1, 0 here. And so we're actually going to get a heck of a lot of zeros here because f of r of t dot product with r prime of t, 1, 0 dot 0, -1 is 0. And so to finish this off here, the integral over c1 of f dot dr equal to integral of t runs from 0 to 2 of f of r t dot product r prime of t dt, and we just end up with 0. So f dot dr, integral of that is equal to 0 minus 0 is again 0. So this integral ends up being 0. And you crunch it out, these two curves here, the integrals shouldn't give you 0, but they should cancel out and end up, like the sum of those two line integrals equal to 0. But that's not how you're supposed to do the problem. We're supposed to do this with Green's theorem.